Okay, so right now I have 0 resistance at the gate, or actually it's probably about 5 ohms or so. It doesn't get to 0, it's almost 0. But anyway, I have minimum resistance at the gate, and this is the waveform, for example. And what I'm going to do is I'm just going to rotate this counterclockwise, and this is going to increase gate resistance. Okay, so I'm going to bring it back to no resistance, or minimum resistance. Okay, now what I'm going to do is I'm going to just turn the dial in one direction constantly, and you're going to see the effect on the waveform doing this at the gate. So increasing gate resistance, and as soon as I just increase a little bit, it's already getting into oscillation. So it's already trying to oscillate. So anyway, but I want to take it out of oscillation, so I'm going to continue in the same direction. Increasing gate resistance. Okay, so right now we're past the point of being able to oscillate it. So what I'm going to do is I'm going to continue to increase gate resistance from this point on. I'm increasing. As I'm increasing resistance at the gate, you would expect the amplitude to be reduced, which it is. And you can see the overall amplitude is reducing, increasing gate resistance, increasing gate resistance, increasing gate resistance. I'm going to open this up so you can see it a little bit better. Okay, I'm increasing gate resistance, I'm increasing gate resistance, increasing gate resistance, increasing, and look, it's growing. The amplitude is growing right here. And as I'm increasing, then it starts to shrink back down. Okay, maybe it's easier to see with a lot of waveforms here. Okay, and so right now I'm at maximum resistance, which is about 5K ohms at the gate. Okay, and the waveform on the load is definitely more negative than positive. Okay, and so I'm at maximum gate resistance. What I'm going to do is I'm going to start reducing resistance. So I'm going in one direction. I'm reducing resistance, reducing resistance, reducing resistance, and you can see the amplitude is climbing. I'm reducing resistance, I'm reducing resistance, reducing, and now at this point it's shrinking. See it shrinking back down. I'm increasing resistance, increasing, and then at a certain point I'm increasing, now it's growing again. Okay, so before it starts growing right there, right now I'm going in the opposite direction. I'm increasing resistance, increasing, it's shrinking, increasing, now it's starting to, the amplitude is starting to grow again. Okay, and it's growing as I'm increasing resistance, now it's starting to shrink. Okay, so there's a nonlinear zone right there, which is, this is about the peak right there of that nonlinear zone. Okay, if I just put these all the way across many samples so you can see with no mistake what's happening. I'm at maximum gate resistance, and what I'm going to do is I'm going to start decreasing gate resistance. Okay, I'm decreasing gate resistance, and you would expect the amplitude to climb just like it is. Decreasing gate resistance, decreasing, it's climbing, decreasing, it's climbing, decreasing, it's climbing, decreasing, now it's starting to shrink back down. You can see that it's shrinking right there. And if I keep decreasing, now it's starting to grow again. So through this range here, which I'm guessing is maybe a couple hundred to maybe 1K of resistance range, it's a totally non-linear region. So I'm going to decrease, or I'm increasing resistance. Okay, actually that's more negative, but it's also the smallest amplitude. Okay, and what I'm going to do is I'm going to increase. You can see that it grew. Increasing resistance, or decreasing resistance, decreasing, and you can see that it's shrinking now. and I'm decreasing, 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 decreasing. Now it's increasing in amplitude. So it's not linear. Right there, I'm reducing, or increasing, 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 increasing. Now it's starting to climb, now it's shrinking again. And so you just got to play with those little zones there. So the lowest amplitude, okay, and when I'm setting the gate, now I'm going to mess with the off time. I have minimum off time right now. I'm increasing off time. Look at that. Okay, this is minimum on off time. This off time is all the way counterclockwise, and so there's minimum on time, and this increases on time. This decreases. I'm sorry, off time. This is 0 off time and maximum off time. Minimum off time, maximum off time. Minimum off time. Okay, I'm at minimum off time with the gate set at that nonlinear region at the lowest amplitude. Now I'm going to increase off time. As I'm increasing off time, that amplitude is absolutely shrinking. More off time, more off time, more off time, more off time. Now look, it's starting to grow right there. More off time. Now it's starting to shrink. So at that point right there is the highest amplitude. And if I just keep increasing the off time, see it shrinks, and then it's growing again right there. There's a little zone right there. And if I keep increasing, then it shrinks back down. Less off time, amplitude increases. Less off time, amplitude decreases. And so there's a little nonlinear zone right there, and if I keep increasing the off time, see, you can see those little cycles of growing and shrinking, but pretty much that's maximum off time. So I'm going to decrease off time. I'm decreasing, 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 and I'm decreasing off time, and you can see the growing and shrinking. So it's totally nonlinear, and that's with minimum off time. And then if I mess with the on time, well, here I'll set the off time to where I'm, let's just say that peak right there. Now I'm going to increase off time, or on time. I'm decreasing on time. Okay, nothing. Now I'm going to increase on time. Increasing, 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 and see it shrinking down. Increasing, 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 and now it's growing again. See, so there's a whole bunch of these little nonlinear zones. You can find them with virtually any pot, even the pot meter controlling the power supply to the 555. If you're using one of those, you can find those zones. So it's maximum on time. So I'm going to reduce on time, reducing, 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 and you would expect the amplitude to get smaller. I'm reducing, but now the amplitude is increasing, increasing, and then it's shrinking. So at that point right there is a maximum amplitude for the minimum, for the on time. It's in that nonlinear zone right there. So anyway, just something to play around with.